Let's study first equation of motion. What is this? This is v equals to u plus at. This is called first equation of motion of uniformly accelerated body. Okay, uniformly accelerated means what? Acceleration is constant. V equals to final velocity. This is final velocity. U is initial velocity. A is constant acceleration. T is, here acceleration is not only acceleration, here it is constant acceleration. If the acceleration will be constant, then only this relation holds. Sorry. The first equation of motion, v equals to u plus at. Here it is, acceleration must be constant. Okay, this is a necessary condition. Then after v equals to u plus at holds. Okay, and here we will read its derivation. There are primarily two types of derivations. One is graphical and another by calculus. Let us at first see the graphically. Actually it is called, this relation is also called velocity time relation. This relation is also called velocity time relation. This is also called velocity time relation because velocity time is also here and acceleration is constant. So the relation is velocity time relation. So let us plot the graph, velocity time graph. This is velocity here in this way, this is time in this way, and let it be initial velocity u. Let us mark the points at first, p, and here it is some other point q, we can say. This is p is showing initial velocity, this is final velocity showing, this is initial velocity u. Okay, leave this p and q. This is simply yes, this is necessary for derivation, point p. So it is u initial velocity, this is v final velocity, and now let at time t, because time is also required before time, this p for u, then it is, let us elongate this and join it with this. What we get this as, this one as v minus u. This distance is v minus u, because this complete is v and this is only u, so the difference will be v minus u, and this is equal to this. Okay, this is v minus u and this one is t, and we know the slope will tell the acceleration, slope of this triangle, this one. This is p, let it be r. Then this pr line, here we will write let it be, here we will write acceleration equals to slope of pr, and the slope of pr is what? Tangent, tan theta we will calculate in this right angle triangle. This is a right angle triangle and tan theta is, you know, p by b. So perpendicular is v minus u, and b is, this is the base, this is equal to this time t. So a equals to this, implies that at equals to b minus u on cross multiplication, and that is v equals to u plus at. You can get it easily. Okay, it is proved. Okay, there is one more method, that is called calculus method. This is by graphical method. This is proved graphically. Okay, this proof is graphical proof. Graphical. There is one more method, that is by calculus. Now by calculus we can see here proof by calculus. This was graphical part. Let us see proof by calculus. At first we will write what is given. We have been given acceleration, that is constant. I have already told you that here it is, acceleration is constant. This is a condition, so it is given. Okay, so it will be written as given, acceleration is constant, and acceleration is constant, so it is, we can write it in calculus, acceleration equals to dv by dt. Okay, this is equals to a acceleration, we can also write it in this way. Okay, so here it is, on cross multiplying we get dv equals to a dt. Okay, now integrate both sides. On integrating we get integrating dv and integrating a dt, integrating both sides. You must write it in the bracket that what we are doing, integrating both sides. Okay, for integration we need what? Limit, and the limits are velocity is changing from what? Initial to final. Okay, and here what is changing? Here time is changing, d is related with t, so time is changing, d is change, and what is changing? T is changing, and so t will change from 0 to t. Okay, t is changing from, we can see from the graph, 0 to t. Okay, this is 0, and velocity is changing from u to v. Velocity is, initially it was u, finally it is v. So we will calculate, this will come to v minus u, this will come to v minus u, and this is a constant, so it will come out, okay, and it will give a value a t, and this is 0, okay. On solving this further we will get this one, so it is v equals to u plus at. This was by calculus method and this was by graph method, okay. So there are two proofs of this first equation of motion, okay. Let us see a numerical. The question is, a motor starts from rest and starts accelerating at 20 meters per second square. For 10 seconds find final velocity. Here it is given items. At first we write what is given. A motor starts from rest, it means initially it was at 0 speed, okay. So initial velocity is 0, it is given, and starts accelerating at 20 meters per second square. It means acceleration is also given as 20. This is given, okay. And one more thing is given, that is t, time, 10 seconds. Time is 10 seconds, okay. Then what we have to find is final velocity, v equals to what? Now we know that since v equals to u plus at, so it is v equals to, initially it is 0, put the values, on putting the values we will get 0 plus 20 into 10, then the value will be 200 meters per second. This is the answer, okay. Thank you.